right, hello guys. This is 5C.8, solving systems of equation by elimination. Now you should only be watching this if you missed this in class, so you can get caught up. Or I guess you could be watching it if you're lost and you just want some extra help. Okay, so solving systems of equations by elimination. The third and final way, because we've learned two others. The first one we learned was by graphing, which was 5C.6. And then last lesson, 5C.7, we learned how to do it with substitution. So this time we're doing it by elimination. Okay, so the third and final way to solve systems of equations is by elimination. Okay, the method of eliminating one variable by adding or subtracting two equations with a common term is called the elimination method. Okay, this method is most useful when one variable from both equations has the same coefficient, and I'll explain that in a minute, or the coefficients are multiples of each other. Okay, so for those of you who don't know, you might want to write this down. So a coefficient is the number in front of a variable. Okay, so for example, in this number right here, with this variable, this -2 right here is the coefficient. Okay, that number that's in front. Okay, so again, we've got a whole flow chart here. Whoa, what happened here? Focus, there we go. Wow, that was interesting. Okay, so we have this whole flow chart for helping us solve systems by elimination as well, okay? So I'm going to refer back to this one back and forth, but we're going to be working on the back side, this problem right here. So pull that problem out, and that's the one we're going to be working on, okay? So solving systems of equations by elimination, personally, I feel is more, other than graphing, seems to be the easiest one for me personally, but it may be a little bit harder for you than substitution. Just keep in mind that on the test and the quiz, it will specifically tell you which method to use, and you will need to use that specific method. You can't just use whichever method you want unless you're told you can. So if it says solve the system of equations by elimination, you need to use elimination, okay? So this is our system right here of equations. Now, step one, if you look at your flow chart or just look here, it says look at the equations. Are they both in standard form? One thing I want to point out is standard form is always ax plus by equals c, where a, b, and c are numbers. Okay, and one thing you really need to keep in mind is that x always has to be before y. Okay, that's standard form. Okay, so are they both in standard form? X, Y, X, Y. Yes, they're both in standard form. X and Y are both on the same side of the equation, and X is first and Y is second. Okay, so these are perfect for us. Now, so we go to yes. Okay, and step two, so we come here and we go to yes. Step two says, look at the equations. Are there any equal and opposite variables? And then here's an example. So 3x and -3x, these are equal and opposite. So they're both 3x, but then they're opposite. One's positive and one's negative. Okay, so we need to see, is there an equal and opposite? You need both. So if I look here, these are both equal, my x's, and one's positive and one's negative. So these ones right here are my equal and opposites. This one and this one, okay? Now if you look at y, you'll notice that those are neither equal nor opposites. So since we have step two answer yes, we're going to come down here to yes. Step three says add together the equations to make a single equation with one variable. The whole point here is to get rid of one of these variables so that we only have one left in our equation and it's easier to solve for. So I'm going to add these two together. I'm going to kind of move my paper over. So I'm just going to copy them down. So 2x plus 3y equals 20. And then I'm going to add that with negative 2x plus y equals 4. Okay, big ol' addition problem. Now make sure like terms are under like terms, okay? The x's are lined up, the y's are lined up, and your constants, these numbers with no variable, are lined up. Okay, so 2x plus a negative 2x gives me 0. 2 minus 2 is 0, so I don't have to write anything there. Those cancel out. 3y plus 1y gives me 4. And 20 plus 4 gives me 24. Okay, so now I'm left with an equation with one variable. Perfect, this is awesome. This makes it super easy to solve for this variable. Okay, so if you look at step number 4, so we did step 3. We added together the equations to make a single equation with one variable. Now we're gonna come over here to step 4, and step 4 says solve the equation from step 3 for the variable. We're gonna solve this one for y. So divide by 4, y equals 6. Yay! Okay, we know what y equals. Again, remember, with our systems of equations, we're always looking for the point of intersection. So far, I have that y coordinate for my ordered pair. Okay? All right, so we're done with step 4. We come down to step 5. Step 5 says substitute the value for the variable you just solved for into the equations and solve one of the equations and solve. We're going to take y equals 6, okay? And we're going to substitute it into one of these y's. Now, I always try to find the easiest one. Now, you can pick either one. It does not matter. I try to find the easiest one. Now, I notice here there's no coefficient in front of y, so that means all I have to do is put a 6 here. So I'm going to use this equation. Now, you could use either equation. It does not matter, okay? So I'm going to take 6, and I'm going to put it in right there for y. So what I'm going to get is negative 2x plus 6 equals 4. Now I'm going to solve this one for x. I do that by subtracting 6. Negative 2x equals, and 4 minus 6 gives me a negative 2. Then divide both sides by negative 2. X equals negative 2 divided by negative 2. A negative divided by a negative gives me a positive. 2 divided by 2 gives me 1. So these two lines intersect at the point 1, 6. Now, remember, I've been asking everybody this, what quadrant does this one fall in? If I was to graph this, which quadrant would it fall in? Remember, this is 1, this is 2, this is 3, and this is 4. Since they're both positive, I would go over and up, so it's going to be in quadrant 1. Okay? All right, now this one. Well, what I want you to do is cross this one out because we're not going to do this one. We're going to make a new one. So this is the one we're going to actually do. We are going to do 7x plus 2y equals 24, and then 8x plus 2y equals 30. Okay, that's the one we're going to do, so I'll give you a minute to write that down really quick. Okay. Now, the reason why we're doing this one instead of the one that's there is because this one is like 3 steps harder than what we're ready for. So we're going to do this one. We'll come back to one like this next lesson. Okay, looking at our flow chart for elimination. Look at the equations. Are they both in standard form? X plus y equals, yes, these are both in standard form. Okay, so yes. Next one, look at the equations. Are there any equal and opposite variables? Well, these ones are not equal or opposite. These ones are equal but not opposite. So the answer to our question is no. So we come back here and we look at no, which tells us to come here. This says multiply one or both of the equations by a non-zero number to create a pair of equal and opposite variables. Now, we don't want to change this 2, right? Because 2 is equal. We just want to make one of these a negative and one of them needs to stay positive. Does it matter which one? No, you can pick either one to make negative, okay? I'm just going to do the top one because it's on top. So in order to make this 2 negative, I need to multiply it by a negative 1. A -1 will keep the 2 but change the sign in front of it. But I can't just multiply the 2. I have to multiply the whole equation. Okay, so I'm going to take this over here and I'm going to take 7x plus 2y equals 24, and I'm going to multiply the whole thing by a -1. That means everything inside of it is going to change its sign, and that's it. So when I do that, my positive becomes a negative, my positive becomes a negative, and my positive becomes a negative. Now, if one of these had been a negative, multiplying it by a negative would have made it a positive, okay? Now I'm just going to bring this down here so I can add them together. So 8x plus 2y equals 30, and we are adding that all together. Okay? All right, let's move this up a little. See what we're doing. Okay. So now a -7x plus 8 will leave me with 1x, but we don't write the 1, we just write the x. Okay. -2y plus 2y leaves me with 0. And then that's going to equal -24 plus 30. So this is like saying 30 minus 24, which is 6. So x equals 6. Look, this one doesn't even have anything in front of it. We don't have to do anything else. X equals 6. We're good so far. Okay, so over here, I'm going to write my ordered pair and put my 6 in my x spot. And now, just like before, so we did step 4. We did step 3 and 4. I kind of moved ahead. So step 5 says substitute the value for the variable you just solved for into one of the other equations. So I'm going to take this 6 and I'm going to put it into one of these equations. Again, it does not matter. You can pick whichever one looks easiest to you. They both look pretty simple to me. There's no negatives, there's no fractions. They all have coefficients. Let's just use the bottom one, okay? So we're going to put that x right into there. Okay? All right, so we have 8, and then instead of multiplying it by x, we're multiplying it by 6, plus 2y equals 30. 8 times 6 is 48, plus 2y equals 30. Subtract 48 from both sides. 2y equals 30 minus 48 is a -18, because 48 is bigger. And then divide by 2, y equals a -9. So 6, -9 would be the point where they intersect. And if I was to ask you again what quadrant it falls in, my x is positive, but my y is negative, so it would be in quadrant 4. Okay? All right. That is all there is to that one. Okay? So you are all done. 5C.9 will be a little bit more complicated, so if you need to watch that one, feel free. Thanks.